Hi folks, thanks for stopping by. Today I'd like to answer some questions from the Flat Earth crowd that seems to have them stumped. You know me, I'm nothing if I'm not helpful. So this question comes from Lori Frary in Sarasota, Florida. And she says,
can you show me empirical evidence that you personally have that we live on a spinning ball? I mean, no one can say yes. Not one person has personal knowledge that we live on a spinning ball.
well, that's an excellent question, Lori. And I'm going to split this into two parts. First, is the Earth spinning? And second, is it a sphere? And I have empirical evidence for both. Now, my first YouTube video was on Leon Foucault, who established in 1851 that the Earth is spinning as opposed to the stars and planets all circling it. That video is about 10 minutes long, and you'll get a much shorter version here. Foucault built a massive pendulum. It's like 60 pounds of lead and brass hung from a 220-foot cable. He mounted the cable into a gimbal, which allows the pendulum to swing not just left and right like a grandfather clock, but forwards and backwards in any direction. Now, the idea behind the pendulum is Newton's first law, which states that an object in motion stays in motion with the same speed and in the same direction unless acted on by an outside force. So, if it swings and returns to its exact starting point, day after day, hour after hour, well, this is exactly what you'd expect if the Earth was stationary. And the Foucault pendulum would be rightly hailed by the Flat Earth as evidence that the Earth is stationary. But something different happens. As it swings, it appears to advance slowly clockwise in the northern hemisphere, counterclockwise in the southern hemisphere. Now, how could that be, with no force acting on the pendulum? Is there some unknown force at work here? Or was Newton wrong? I kind of don't think so. Well, there's no force acting on the pendulum causing it to move or change direction. But there is one on the room housing the pendulum. Now, while the pendulum swings, the room housing it is rotating counterclockwise at about half the speed of the hour hand on your watch. So you need like superhuman senses to detect that. But over time, the pendulum reveals what your senses cannot. They tell you that the room is motionless, but your eyes see that the pendulum is advancing clockwise. Actually, it's the room that's rotating counterclockwise. Now, the Earth rotates 15 degrees per hour. The speed that the room rotates per hour relative to the pendulum is found by multiplying 15 by the sign of the latitude where the pendulum is located. That's what ties the rotation of the room back to the spinning Earth. So, Lori, there's a historic Foucault pendulum about an hour's drive from you in Tampa at the University of South Florida in the Math and Physics building, and it's free. So I say historic because the Tampa pendulum has been operational since 1851. Okay, that's the year Foucault built his in Paris. So when the news broke, they immediately reproduced and confirmed Foucault's experiment. And I have to say here that I was surprised to hear that and really impressed. You live right next to possibly the oldest Foucault pendulum in the United States. So please visit them. You know, I am certain that they'd be thrilled to hear directly from a noted flat earther what the explanation is for why the Foucault pendulum does what it does without the Earth moving. Now, we've established rotation here. So let's take a look at the ball shape. Now, flat Earth people rightly say, "Oh, it sure looks flat to me. Where's the curve?" Well, the Earth is so enormous that you can only see 1/1,000,000th of it from any location on the surface. You know, if you were like the size of an amoeba and you were living on a banana, it'd probably look flat, you know, because you don't see enough of it. Well, it's a matter of record that in every lunar eclipse in all of recorded history, the shadow seen on the moon has a curved profile. And this is a thing that you can witness yourself. In this photo, we see about 1/8 of the total curve of the Earth. We see about 3,000 miles of the profile, and it's a clear curve. So we know from the Foucault pendulum that the Earth is spinning. So think this thing through. Now, what shape is it that always has a circular shadow, even when spun into any position? Would that be a cube? Maybe a pyramid? Well, I kind of don't think so. The shape that best answers this little puzzle is a sphere. Okay? So the Earth is a sphere. You can see that for yourself with your own eyes at the next lunar eclipse. So check it out. And you can see that the Earth is rotating from a Foucault pendulum, which is only a 1-hour drive away from you. So I think you put those things together, and this is the empirical evidence that you're seeking. Okay, well, that's really all I have to say right now, and thanks for watching. It was kind of fun to make, and please check out my other Flat Earth videos, especially the one on Foucault's pendulum, and I'll see you next time.